Okay, I think we'll start. I'll get rid of my demo. Well, I won't get rid of my demo because I think I breathed a sigh of relief that actually fired up. Of course, I knew it had fired up, but of course, when there's people watching, there's going to be something happens. Right. And because the screen resolution's dropped so low, I actually don't know how to use the menus. Alrighty, okay. So my name is David Glover. I'm a developer evangelist at Microsoft. And so my role is to kind of get out there and connect with developers. That's my day job. Be it in the community or be out in partners or customers is kind of where I fit. And if you're serious about doing things around Internet of Things, particularly on the enterprise space, then do feel free to reach out to me. Those who feel free to reach out to me anyway. I kind of a vague presence on Twitter, so I'm dglover. dglover@microsoft.com is probably the best bet. And I try to be not too bad at email. I wouldn't confess to being the most fantastic either. Twitter or things like that are quite good. Just a bit lower bandwidth. Right. Okay, we'll get a little video. We'll play a little video and give you a sense of what we're doing.
The future holds. Imagine if you could connect the dots to see beyond where your business is today to where it could be in the future. Would you begin to see ways to make improvements? Or see what once seemed impossible is now within reach? Technology is rapidly accelerating the transformation of your business. It's changing the way we work. Imagine if the most vital parts of your business were connected: people, assets, processes, and systems. Everything from your factory floor to the field. With the Internet of Things, they can be. And simple changes can transform your business right now. With the Internet of Things, you can extend your business's reach and make better use of its resources. Data that was once untapped is now an asset. Even the most critical issues can be solved in real time. You can see ways to make the most of every moment. The reasons why you should embrace the Internet of Things are clear, but how do you get started? We believe the Internet of Things begins with your things, the things that matter most to your business. Start small, from where you are today, and build from there. Make the most of systems you already have in place.
Alrighty, you probably get the general sense of it. Now, there was a really good reason why I played that video, besides dancing and tap dancing for a bit of time. It kind of gives you a sense of what the game is for Microsoft and where we're kind of focusing our attentions around the Internet of Things. It's very much into enterprise and business. And though we call, of course, Internet of Things has become the new trend and everyone's talking about it and everyone blah, 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 we've been doing the Internet of Things for at least 20 years. And the Internet of Things has really been going on probably for the last 40 to 50 years. If you think about process control systems, SCADA systems, all those types of systems out there, they were fundamentally Internet of Things. So we've been doing embedded. So you would have heard of Windows Embedded and those types of products for a long time. But what we've done is, because the Internet thing has become the new thing, all those products and platforms and technologies that kind of lived a bit on the outside of the main thrust of Microsoft, particularly around Windows and the platform, have now all moved into be part of the Windows team. So that's the biggest difference. And so the innovations that we bring out into Windows, Windows 10, the kernel, all those types of things now go into our Internet of Things enabled products and platforms. So that's very much where it goes. And it comes all the way down to things like security. And I'd say security is kind of like the number one thing. If people ask me what's the most important about Internet of Things, I say security, security, security. And then anything after that is kind of interesting. Data is obviously very interesting. But for enterprises, security is kind of those number one priority. And what we're doing around the platform, all the way from the client platforms up to the cloud, is ensuring that business can do that with confidence and security. So that's very much, so it's kind of why I played that video, because you kind of get a sense of where we're going for. and it's to work with folk who are building systems out. Now that said, I would say that this session is part enterprise and part maker. Is everyone comfortable with the term maker? So most people's heads are going, yeah, so people to go out there and fiddle with electronics and build something, craft up something, garage door openers, pianos, whatever it is, drum kits, might be things. So I'm going to give you a bit of a sense of both. And the demos that I'm going to show you are kind of erring on the maker side, but they're using enterprise technology. So I've kind of made them, you know, a bit funsy and a bit fun. Now, all the code for these demos lives up on my GitHub. And so my name's Dave Glover, and unfortunately someone nicked Glovebox, so I went for the plural. So that's where you can find me on github.com/gloveboxes. And you'll find all the code that are in these demos, plus way more than you possibly ever really want. And I also develop code up there and code samples up there, obviously around Windows. I'm a bit of a fan of Arduino, so there's a lot of stuff up around Arduino. And I even kind of hack, I really am a hack when it comes to things like Python. I can kind of hack my way to joy on Python. And I look at the language and say, oh, wow. And then actually sometimes I really hate it, and then sometimes, oh, it's actually quite cool. So you'll find my code across those kind of range of products. And the other thing that we do, in fact, I'll jump around that in a moment. Okay, so I mentioned before, yeah, so this session's kind of a bit about the driving forces, opportunity, and development. And I kind of want to step back for a moment, because I mentioned before that we've really been doing the Internet of Things, so I would say 40 to 50 years. It's probably even, 50 years probably feels about right. And so what's different now? The biggest difference is really around commoditization. So if you had an awesome idea 10 years ago, 5 years ago, and you wanted to take something to market, you might have to go and mortgage your house to go and build something, to go and get the technology to put it all together, go along and find an organization who was willing to invest with you and actually go and build something. And it would typically cost hundreds of thousands, if not millions of dollars. Certainly 10 years ago, 20 years ago, these types of projects were in the millions of dollars. Now, as we know, things like the price of silicon that's sitting inside our mobile phones, the ARM processor in that, they're like a couple of dollars. So they've really, the whole commoditization has really changed to the point where I might be wearing a Fitbit, all those types of things. Those products are immediately accessible because of cost, a big part of that. The other thing that's changed, obviously over the perhaps last 5 years, is the advent of commoditization around compute and storage. So really around the cloud. So you're seeing these really tiny devices being able to collect data, but fundamentally they need to be able to push the data somewhere. And we want to be able to do that at really cost-effective rates. And again, that's exactly where cloud computing comes in. And I've pulled out one other factor in here that I think is really quite amazing. It's 3D printing. And the idea now that if you want to go along to some crowdfunding idea, they typically want to see something kind of, how does this product look? And the advent of 3D printing is really going to revolutionize manufacturing. You've only got to look around. I think in China, I think I spotted an article maybe 6 months ago where they're printing houses and printing places where people live. So really that whole thing's changing. But certainly with the Internet of Things, the idea about a prototype and build something are really amazing. The other thing I'd say, and I've kind of touched on this, is really the access to capital. And that's the other thing that's really quite different. If you had a great idea, you typically had to go to a large organization like Hitachi or General Motors or people like that who had kind of the manufacturing clout and say, look, I've got this great idea. Can we get out there? Now we can go out to crowdsourcing and crowdfunding and Kickstarters and say, look, I've got this awesome idea. Put in a $5. I get enough people to put in a $5. I've got enough money to go and take my project out there. The other thing I would say, and particularly for enterprises, is this hunger for knowledge. And if you think about most of all our organizations, what we do is we go and build product or service and we ship it out somewhere, and often that's the last time we can kind of interact with it. And so organizations are grappling with this idea about how can I get the information back from and understand how people are using that product or service I might be using, and how can I get that back into the system to understand what I can do to manufacture and be smarter and things like that. So I really say that's a huge difference there. There's this whole big data thing that's going on. machine learning, be able to kind of look at the data and kind of build out and understand patterns of the data and things like that. The other thing that I would say that's really changed is the whole open source movement. And you might think that's kind of weird, Microsoft talking about this open source, but we do this, and I've got to say, Microsoft has changed immeasurably over the last 5 years. So I think we kind of came from a point where we were actually pretty open, and then we kind of got less than open, and now, man, we just open source pretty much everything. So all the way from our developer tools to the .NET framework to visualization frameworks to a whole range of things out there have really gone open source. So we understand kind of the open source world for software, but what's happening is that open source is happening to the hardware world as well. And that's one of the other things that's happening. So you'll find that things like Arduinos, they're an open source reference, open source hardware reference. I could take that reference implementation and I might have a great idea and go manufacture my own Arduinos with some sort of, whistles and bells on it. And I could do that quite legitimately. I could take that fab design and then go off and manufacture. So those are some of the big things. And the other thing is this kind of this maker movement is kind of happening again. And I think we've gone from a point where we think about computing, a lot of the kids nowadays, I think a lot of us complain, they can use PowerPoint and Excel, but actually they understand how the computers work. And I think there's this whole move back towards STEM, the science, technology, engineering, maths, and people getting back to building stuff again. And I think we're seeing that whole revolution happening as well, where people want to get out there. And you've only got to look around on YouTube, and it's just full of this stuff that people are going on, and it's just building up a knowledge base so people can actually get out there and build things. So to give you an idea what we're trying to do in the Microsoft kind of vision of things, it's about, so we're building out platforms, the client-based platforms, which can actually enable you to get that data, and to be able to get that data into the system and then start being able to build things out there. So start being able to understand what the value of that data is. So that's fundamentally and that's a lot of what we're providing in our cloud services, be it around Power BI or Stream Analytics or storage or all these types of things. It's fundamentally what we're trying to do in terms of our overall goal is to really harness the intelligence out there in these systems. And really the other thing we're trying to say is, for organizations, and I'm sure the organizations you're in, they're thinking about this Internet of Things. And our general advice and guidance is try not to boil the ocean. Try and come up with an idea that you can say, look, if I could change one thing in my business, what would it be? And if I could gather a bit of that data, rather than trying to say, we could do this and this and this and this and across the organization, wouldn't it be fantastic? Our real goal is to try and find one thing out there that you can kind of do. And then hence why you try to see it, this whole idea of Internet of your things. And in terms of the opportunity, now these numbers vary. I have to confess, 2 years ago, I was using a number, I think it was 200 billion devices by 2020. And this number has been rounded down now to around about 25 billion devices by 2020. And it's actually a reasonably achievable number, and I'll show you why in a moment. And I took a rough number of 3%. So I think Australia's around about 3% of GDP. And I know this, you can't necessarily say, well, we've got 3% GDP, we're going to have 3% of the Internet of Things devices, but just go with it. I think that came to about 750 million devices in Australia. And you might be thinking, well, who the hell is going to be using all these devices out here? And to give you a sense of where that might be, and I'll talk about this in a moment. Well, hey, sorry about this. Yep. Sorry about that. To give you a sense of what we're doing, we have something like 125 buildings on our campuses, which we have internet enabled. And we get something like, 500 million data points per day of information about what's going on, how our buildings are being used, so we can control things like air conditioning and lights and all those types of things. And we save around about 10%. Now, when I talked about this number, about this 25 billion number, one of the biggest things I see in Australia, and this is kind of made about the point. When I talk to people about Internet of Things, it's often about agriculture. So it's often about being able to track animals. There was a project in Victoria which is looking at, which actually does this. They put little sensors on the back of bees, and they actually track where they are going around. Does anyone know why we're doing that? Anyone? What's that? They're dying out. Yeah, bees, it's a fundamental problem to our agriculture, probably to our lifestyles, to our life. Given that we're so dependent on bees pollinating everything, is that bees are dying out. And so this Internet of Things project was, they literally put these little, effectively an NFC tag on the back of these bees, which I have to confess I think probably contributes to their dying out. And they were basically flying around and they're looking to understand where these bees are going. So when you start thinking about agriculture, you try to think about the mining industry, finance sector here in Australia is big as well. These are kind of where our numbers come from. So clearly most of us are kind of either carrying phones, which are maybe tracking our steps, or we've got Fitbits or whatever other device out there. We've got all these things out here. So it doesn't take too long for all these devices. And of course, we're getting down to very small and very cheap devices. So this is kind of where the opportunities are. Now, the finance sector is absolutely ripe as well for Internet of Things. And again, when I talk to people, it's in this space. And again, the examples I'm going to talk about are real. So for example, in the finance, in the insurance sector, you can pay a lower premium if you're willing to share data about how you drive, or maybe you live in a flood-prone area, so maybe you've got a sensor in there which looks at potential flooding, and so that you get early warning on flooding. So there's a whole range of things out there, from health, for our own health. If I'm prepared to demonstrate that I walk 10,000 steps a day, for example, I might get a lower premium. Flooding. In the US, I think it's General Motors and Ford now instrument their cars, I should say, and they are streaming, I think it was something like 25 gigs a day of data from all the cars across the US for those makes and models. So you get the whole ability to be able to get preventive maintenance. Hey, look, the car's playing up, the emissions are high, or something like that. Maybe you should go and get the car checked out. But so those are kind of some of the opportunities. Now, in terms of what we're doing around Windows 10, so hopefully you all appreciate that what we've been doing is trying to get to one platform, one API. So if you go and build a Windows application on Windows 10, it'll run across a range of things, from HoloLens to Raspberry Pis, to embedded devices, to desktops, to tablets, to phones. And so that's kind of what we're trying to do with the platform. The other focus of what we're doing is around security. And obviously enterprises really care about security. And they care about it on their desktop, they care about it on their kiosks, and they care about it all the way down to the smallest devices. And that's really kind of what we're focused on, is making sure that all the technologies that we build around security or software patching or all these types of things are available from the Raspberry Pi product that I've got sitting inside this robot, all the way up to the largest financial control system. So we kind of treat all those technologies, go into the box, and are part of the deal. And the other thing is really about being connected. Clearly, that's kind of what the Internet of Things is about, and being able to do that securely and things like that. So we've got the universal platform. So not only have we done the universal platform for applications, so from a software developer's perspective, we can go and build an application across these platforms, but from an OEM, original equipment manufacturer's perspective, they can go and write device drivers once, and they will work across all of Windows 10, be it on ARM, be it on x86, be it on x64. So that's the other thing that we've done with Windows 10, again, is just to make that more accessible from people who are building applications to people who are building system level. And I've kind of talked about all these things. Now, we have a number of editions of Windows 10, what we call IoT. So we have a SKU now, so we have basically desktop and we have phone and things like that. but now have it, and this used to live in the embedded world. So if you have been around Microsoft for a while and you kind of wondered where the enterprise embedded version went, and heck, is Microsoft pulled out of the market? No, we have absolutely not. It's morphed into Windows 10 IoT Enterprise. And it's there for driving process control systems and kind of enterprise grade things out there. And there's often a legacy, a significant legacy of applications and control systems and experience and all those types of things. So on that platform, we support Win32 applications, so native Windows 32 applications, plus we support managed applications, so the universal Windows platform-based applications. So as I said, it's really targeted towards enterprises and process control systems. It would be the kind of stuff you'd find in an Hitachi lathe, for example, or those types of really kind of big industrial types of things. Now the other thing we have, and again we've had this for quite a while, it was under the embedded platform, but we have this thing called Windows 10 IoT for mobile. And again, there's clearly one iteration of that is the mobile phone. That's one SKU of that. But also Windows IoT Mobile goes into lots of other devices. So things like they're scanning for retail systems. When you go and do a stock check. Those the types of systems that would have Windows 10 IoT Mobile built into them, and then people go and build their applications on top of that. So handheld devices, but you're really looking at running UWP applications only. Now, the one at the bottom here is the one I'm mostly going to talk about, and this is called Windows 10 IoT Core. Now, Windows 10 IoT Core is a free of charge license. There is no cost. You can go up into dev.windows.com/IoT, and you can freely download the ISO for it, and you can build it, you can manufacture it, you can do your heart's content, and get out there. So the enterprise versions cost, the mobile versions cost, but the IoT Core is a free of charge license. And I will talk about there is a slight skew on that, no pun intended, in a moment. And as I said down here, it's optimized for small footprint, down to quite a considerably small footprint. It can run I can run background tasks, UWP background tasks, and you can run kind of like a kiosk application. So a single shell if you want, which could be a UWP application. And it's built on low-cost silicon. Now, apologies, I just wanted to double check something. Yes, okay, cool, I have got it here. So we did announce in the last version, the last push of Windows 10, which I think was around about November, so 1505 I think it was, it happened in February or November, kind of in that range. And we did introduce another SKU for Windows 10 IoT Core, and that's really for OEMs. So if I step back a moment, so the Windows 10 IoT Core that I talked about, which is free of charge, you can download it, that fully participates in Windows Update, which you might say, that's a fantastic thing. I really, all software, be it from Microsoft or whoever, invariably needs to be patched. I think the expression, if you can't patch it, you can't secure it. So that platform automatically participates in Windows Update. Now there are some scenarios which you might say, well, hang about. It doesn't suit me for Microsoft to go and push out a Windows update. I'm running this application in retail, for example, and there's no way that I want anyone to touch my system when I'm going into the Christmas period because it's a retail system and everything's locked down. So we brought out a special SKU for OEMs that you can get hold of through OEMs, which is a very small fee, and I can't remember, but I'm talking the dollars. And in that one there is the ability to control the update for precisely the reason I said before, that some organizations just want to be able to control the release cycles and the patching that goes onto these devices, just because there are often some very critical times out there for applications. Okay, so I've kind of touched upon IoT, and I've touched upon IoT Core, and I've touched upon the OEM SKU of that, which you've got more control over the update process. Now, for most of us, when we're building stuff, I'm assuming, has everyone heard of Raspberry Pi? I'm guessing so, yeah. And I'm hoping you all know that Windows 10, you can download for free, you can put it onto your Raspberry Pi 2 and above, and you can go and build applications for that. Now, in terms of, and that's great. So, but in terms of commercial platforms, what we do when we go and build, Windows 10 IoT Core, we build it for one platform and two system on a chip platforms. So we go and build Windows 10 IoT Core for the Qualcomm Snapdragon. We go and build it for the system on a chip Intel Atom E3800, and we go and build it for the platform, which is different. We go and build it for the whole Raspberry Pi. So the idea behind it is I could be an OEM, and there are a lot of OEMs who are going out there and building it. So I could be an OEM saying, look, I have a relationship with Intel, I've done it for years, I'm going to go Windows 10 IoT Core on an embedded board that I've been selling out to retail for forever, and I'm going to put Windows 10 IoT Core on that. Or maybe I'm going to go on Qualcomm. So those are the kind of differences. So these have traditionally, and these are your traditional kind of folk who go out there and build commercial systems, embedded systems, and they're going to do it. And we go and build Windows 10 IoT Core for that. Now, we go and build, obviously, Windows 10 IoT Core for ARM based on Raspberry Pi, but on the Raspberry Pi it's different because we go and build for everything on that board. We build for I/O, we build out for video out, we build out for networking, the thing that the operating system does. And so we go and build out that, and then people can go out there. Now, the reality is that, in fact, all these boards here I'm showing, all have developer board versions of their platforms, except for Raspberry Pi. Raspberry Pi, well, no, it's not true. So Raspberry Pi, these are developer boards. And yes, there's nothing to stop you going out to the market with the Raspberry Pi-based solution. And I know a number of partners who are actually going to do that. Said, look, we've looked at the construction of the Raspberry Pi as it stands, and we like it, it meets our needs, we're going to put an SD card, build our application, and we're going to put it out to market. And there are some people really doing that. And people are also doing it on these other platforms. What you can do, and what we kind of recommend for the Raspberry Pi, is you go and talk to Element 14, I'm sorry. Yeah. And you go to them and say, look, I'm building for the Raspberry Pi platform, and I don't want to ship it out on the retail version of the Raspberry Pi. I want you to go and build me one which has got, 4 gigs of RAM. And it's got 2 gigs of flash memory built in. And it's going to have this network peripherals and things like that. So you go to the Element guys and say, look, can you go and build me this? And I'm going to build my application and put it onto that platform. And then I go out to market with that. Now, the reality is that takes more money and it takes more time. So I do know that there are partners out there just going out on Raspberry Pi. But just kind of keep in mind that Raspberry Pi really is a developer board. Wasn't really designed to put out into production, but people are doing it. But you'd really go to Element and say, look, I want to go and build these platforms. Okay, so the next thing I want to talk about is what we're doing around security. So we have the same level of security all the way from boot, so from secure boot, all the way up through the stack. So all the drivers and all that type of thing are signed. So we have secure boot, and if you know, appreciate under Windows 10, that's how it works. The bootloader loads up, and then will only load in securely signed drivers. And you basically get a stack which is only made up of certified and signed drivers. That's kind of how Windows works. The whole idea is you can't go and put low-level drivers in there to go and do keyloggers and things like that. The other thing about it is we also, amazing enough, have BitLocker support in Windows 10 IoT Core. Now, you do need a TPM. So, gosh, who remembers what TPM stands for? Trusted Platform Module. And that was something that would typically be built in by an OEM, and there would be a key on that. And then you would go and encrypt the disk on your Windows IoT Core platform, and you would get a fully secure boot stack, and you get fully secured encrypted storage, which is just amazing on a device that's really kind of very much a commodity device. You get all the cryptographic support, you get Windows Update support, all those types of things You get universal memory, universal Windows applications. You kind of get the whole capability model, all those types of things that we kind of want when we're building things, like managed memory and signed executables and all those types of things. So that's kind of the investment. We've taken those whole investments out there we're building into Windows and taking it down to pretty much free platforms out there on these types of things. Now, I've kind of touched on this, and I think this is perhaps even getting to be a bit old news now, but I'm hoping most of you now appreciate that the whole push behind Microsoft over the last 5 years is to converge the platforms. And we really are pretty much the main platform out there which has really managed to converge them all down to pretty much one API, the Universal Platform API. So be it phone, be it Windows 10, the desktop, tablets, and Windows IoT Core. To HoloLens, the things you can put across there and have those kind of virtual reality type of experiences. So in terms of building applications, what do you need? So you go and build out there for Universal Platform. You need Visual Studio. You can get the Community Edition, which is free. So if you're a home hobbyist and a hacker and you want to play around with this, you can get all the tools out there for free. You need the Windows 10 IoT SDK, which is license free. You can build two styles of applications. You can build headed applications and headless applications. So a headed application would be like a kiosk app. You come along there and maybe you've got a touch screen on it and you go tap, 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 or you've got a keyboard, and you kind of build out an experience. Headless applications are really just background. So there's no UI involved in them. They're just providing data collection services, things like that. There's a web management interface, and for the real diehards, and actually it's pretty cool, and I'm not sure I'd be a PowerShell expert, but you can PowerShell into these things. And you can manage them, or you can SSH into them, and you can remotely manage them, or do all those kinds of things. So you can kind of do all the things you'd expect and be able to want to be able to do. Okay, so what I'm going to do in a couple of moments, we've got a couple of demos. So the place to get started is absolutely dev.windows.com/IoT. And up there, there's a nice wizard for get started and all that kind of stuff. And you can click on those links and download the ISOs and download the dashboards, all those types of things. Now, the other place that I love, and I must admit I spend way too much time on this site, is hackster.io. Does anyone else spend time on Hackster? No? Okay, cool. Well, if you want to learn a bit about the maker community and what people are building, all those types of things, then head to hackster.com. So there's two ways you can get it. You can head to hackster.io, Microsoft.hackster.com. And that'll take you up to the website, and then people like myself, and I do publish up there, we publish up our software, we publish up our hardware design, all those types of things, and then people kind of get to share it. And we get to share it out there. So it's a great place and great set of resources. Now, in terms of languages, now the Maker Den that we've got out the back are all C# based labs. But like building for the Universal Windows platform, you can pretty much use not every language, but a lot of languages out there. So you can go and build applications in C#, C++, Python, Node, VB.NET for the real diehards. There's a full remote debugging experience, which is just amazing. So if you've done any embedded development, you'll appreciate the lack of remote debugging. So the idea is that invariably you want to be able to debug something in situ because it's got the sensors on. You want to find out where the heck is this code going wrong. So from Visual Studio, you can basically set breakpoints, the code executes on the device, and the debugger works basically backwards and forwards on the network. By the way, I would thoroughly recommend you do that over Ethernet, because doing it over Wi-Fi, it's a bit sluggish. The other thing that we've got on there is we have extensions for UWP. And we expose out kind of all the gubbins or all the hardware interfaces on the platform. So we enable you to get a general purpose input-output ports. There's something called I2C or I2C, or however you come from, which is a standard bus mechanism. So you can have multiple I2C devices all basically sitting on a bus with different addresses. And you can say, I want to talk to the temperature sensor, which lives on address, 75. And another one which maybe lives on 90, all those types of things. You can talk to SPI, pulse width, and universal asynchronous and receive transmission. The other thing that we also support is Arduino wiring libraries. So there's a vast library of software out there, collection of software where people have built for the Arduino platform. And you can use that on Windows 10 IoT, so you can basically import them. Now, it's not going to be true that you can bring in any arbitrary Arduino project. Does anyone know why? Java? No. Okay, it's a bit obscure. It's not obscure until you start doing it. Arduino and all these platforms are often really timing sensitive. So Arduino is not a multitasking operating system. It is a hard real-time operating system, and a lot of that code runs with the expectation that it is the only thing running on that bit of hardware. Whereas Windows 10 is a general purpose operating system. And there might be memory management going, there might be someone doing network traffic, there might be blah, blah, blah going on. So you can't guarantee timing. So there are those are the reasons. There can be some Arduino libraries which are going to port across beautifully, because maybe they talk to another hardware device which is not particularly timing sensitive. And there's a lot of work being invested in it for software and that, and you can bring that across. Now, the other couple of things in here that are really quite unique. The first one I want to talk about is speech services. So built into Windows 10 IoT Core is both voice recognition and synthesis of voice, and it works really well. It's nothing to do with the cloud, it's nothing to do with Cortana or anything like that. There's a speech recognition built into it, and it really does kind of work. You give it a vocabulary, so you need to constrain it. It can't go and understand every sentence and language and everything out there. The synthesis is amazing as well. You give it a string of text, obviously a reasonable string of text, and it will go and read it back to you. And it works stunningly well. The other thing that we've put into Windows 10, again, across the platform, is this thing called AllJoin. Now, how many people have heard of AllJoin? We've got a couple of hands going up there. Okay. So AllJoin has come out of the All Seen Alliance, and it's a really important, and it's trying to address a really important platform issue with Internet of Things, and that is basically the lack of interoperability. So if I go and take someone's IoT project from, I don't know, Hitachi, someone's from LG, someone's from Apple, someone's from Microsoft, someone's from Google, you can imagine all these products out there that are all talking, often quite proprietary protocols. Turn the light switches on, and there might be quite a proprietary mechanism by which my phone might talk to a back-end switch to flick the light on. So the All Seen Alliance and the AllJoin Alliance is an industry-wide move to address this interoperability issue. And interesting enough, I think in 2015, it was the most successful open source platform. Now, does anyone know who it's sponsored by? And keep in mind that we've put all this technology into Windows. It's sponsored by the Linux Foundation. And it's just amazing. I've been at Microsoft for over 20 years now, and I have to say, just to see the change that's going on. So we're actually working with these industry groups, and in this case, it's been driven by the Linux Foundation about how to solve this interoperability issue. So I can go to all a range of different manufacturers out there, and I can go and start to interoperate. It's not going to solve everything, but it solves a lot of those kind of issues. So when I say Microsoft has changed, and I talked about before open source, it's fascinating to see what we're doing, taking those technologies out. We're working with the industry, contributing into these open source Linux Foundation, and then rolling that technology into Windows. And that's really kind of what's going on. So I'm going to give you a very quick demo, and it's really just to give you a sense of how this stuff works. So the first thing I've got up there, you can see I've got this little gizmo, and on top of it, there is an ultrasonic sensor. And I'll show you kind of what, and basically it's sitting on top of a servo, and it's going backwards and forwards and backwards and forwards, and it's just recording the distance. And if I come down here, there is an application now. So you can, what I'm doing here is normally I would have the output being displayed over HDMI, but that kind of gets a bit messy. So what we've done, we've effectively done remote desktop for Windows IoT Core, and you can now do remote display of your UI. So if you're building out some sort of UI experience, wait, it's kind of stopped and started. I think I might be doing it over Wi-Fi, which is probably a little bit dodgy. Let me just go back over here to Sonoscope, and we'll connect up to it. Okay, and if I come in front of it and I stand in front of the ultrasonic sensor, you'll see that's picking me up those orange dots. And it's literally, it's like a bat. And it's sending out signals. Is there anything there? And I think it measures up to about 3 meters. I think that was a reasonable distance. And it's saying, and just picking it up. And then I'm just using standard Windows 10 UI technologies. It's a XAML-based application. So if you're familiar with going into Blend and building out an application for Windows 10, that's what is running here, and it's just using some open source controls, which are little pie charts. And there's literally 1, 2, 3, 4, 5, 6 pie charts that are done to get that kind of radar effect. So that's kind of how this application's running, and I said, it's just sitting there chugging away. Now, the other thing, and I don't know if you can get in close enough. I can. Well, hey, it did work. So hoping this would be a nice, easy way of demonstrating this stuff. Now, this kind of builds on a point I made before, is that Windows 10 is a general purpose operating system. And some things require really hard timing. So for example, to turn a servo backwards and forwards, you basically send it a pulse of a different length. So if the pulse is slightly longer, it will change the position by which the servo will change. And it needs a really precise timing. So you can see just in here, if I move my mouse over there, see that little gizmo on top? What that is, it's a little Arduino chip. And what I've done is I've built a little application which is running on the Arduino, and it's talking over I2C. And I2C, it's just like Ethernet. It's just like a bus. So you can basically send messages backwards and forwards. So my Windows 10 application, which is a general purpose operating system, and it's not fabulous at doing really, really precise timing. So basically what I do from Windows 10 is I hand off to the Arduino and say, hey, look, I want a pulse of 70% in this case, of duration. And it would move the servo around 70%. And that's kind of how this stuff works. Now, what I also decided, and in fact, I didn't really have to do this, but I did in the end because I wanted to hack around with it. I also send a command from Windows 10 to the Arduino to ask the ultrasonic distance to do its measurement. So I actually offload quite a lot except for that UI, which you can see up here. So the Arduino Windows 10 is mostly just responsible, and not even doing that particularly well because I think it's just pushing it over Wi-Fi. So Windows 10 in this case here is really just responsible for the user interface. And it's responsible, so every time every second, every 2 seconds I think it might be, no, every second I move 2 degrees. I just send a message off to the Arduino over I2C saying move the servo 2 degrees, and then while you're at it, I want you to do the measurement, and then I want you to return back the result back to me. And that's kind of how this stuff works. So that's a great example where if you're building out applications, invariably you need to mix technologies for these things based on kind of scenarios. So the other thing I want to show is the remote desktop. So this is the Windows 10 portal. And you can see, if I can come into here and you can get, well, what version of Windows 10 I'm on. And I think this will automatically update tonight or tomorrow. In fact, that is the release build, I believe. And I can come in here and I can see the apps that I'm running. So you can see these are the apps. So you can see this thing down here called Sonoscope Distance Mapper. It's a foreground app, and I can set it to be the default app. And I've got other applications which can be the background. I can go and look at things like performance. And you can see there's really not an awful lot going on this demo on the device, because you remember I said I'm handing off most of it to the Arduino. I can go and look at I/O. Most of that I/O is probably the fact that I'm remotely demonstrating the UI There's probably not really much I/O going on there. And you can go and see the amount of memory and things like that that's been used. Now, one of the limitations that we have on Raspberry Pi is that we only have the basic display driver builder. We don't have an accelerated driver. I believe that we have kind of said we will do it, but we don't have it yet. So do be aware that when you're building XAML-based applications, don't go crazy, because there's a software renderer. You can go and look at the network. You can go and look at Bluetooth, what Bluetooth devices, audio devices, and if I can go into TPM. I might have a real USB TPM, for example, when I talked about that trusted platform module. And down the bottom there is this thing for remote, and I've enabled Windows IoT remote server, which is basically allowing me to do this remote display. So that's the first demo there I want to show you. Now the next demo I want to talk about is mostly about OR join. And what I'm going to go into is I've got this application up here, and it's called the IoT Explorer for OR join. And it is a generic OR join listener. It just goes out into the network, and well, basically, if anyone does a broadcast, say I'm an OR join, it will pick up those messages and say, okay, and then just presents a list of all the devices that are OR join. And what I'm going to do is I'm going to go across to the Sonoscope, and you'll see that the Sonoscope has 4 interfaces and 3 methods, and surprise, surprise, it's got start and stop in there, plus I've got speech in there as well. But so if I come across here and just minimize that up over here, and I'm going to go and hit the OR join method on that, and invoke it, it hits stop. So what I've done here is I've used a general purpose OR join explorer, and you can see I'm interacting with this application on the platform here, which is an OR join enabled app, which I'm going to show you in a moment. Now clearly this is not the application you would put out to your consumers. You would go and build a nice phone application on Android or iOS or Windows or whatever it was, and you go and build that. But this is really just to demonstrate that this really is a universal. So I could have an air conditioning unit from LG or Hitachi or something like that, which might be OR join, or Hue lights. I think Hue lights are OR join enabled. I could have those in my house, sit in the Wi-Fi, and they would expose out OR join interfaces. And that's how kind of connect to these things work. So I'll just shut that down, and I'll just, for a moment, yeah, so we'll keep it. So I hope you've got a bit of a sense of that. Now, the next project I want to show, yeah, actually I'll just jump across here, back into the OR join Explorer. Now what I've got is another project over here, and I'll put this in front of the camera, and it's the same principle. In this case here, I've got a little robot. And yeah, it's a robot and things like that. It's hardly enterprise, but it is also OR join enabled. And in this case, I did actually go and build an app, and it's called Rover. Let me just go and double check that that really was, yeah. And you can see for a moment, and then there should go lose the gray. So this would be an example here where I've built out an app which is now talking over the OR join protocol. And you can see, if I kind of snap that over there, that if I go forward, you can see, voila, and I go left, right, stop, reverse, yada, yada. And I can obviously, because it's actually bridged over my phone in terms of networking, so it could rove its way around here. But the important thing I want to get across there is that it's OR join that's doing that interop. And you can see you can go and build out an experience to go and do that. And what I wanted to show very briefly. Sorry, I should have had this loaded. Now, in this project, I've got some XML. Yay, the world can't get enough XML. And what this is that this is a definition of all join. So in here you can see, apologies if I make it a little bit bigger. Not that that's that exciting, but I showed you the user interface for that. I showed you from the All Join Explorer. So it's basically just a bit of XML, which you go and describe the methods. In this case, I've got a start, stop, and speech. I could also go and define properties, and I can also define events. In the All Join world, they call them signals. And you might have something which is, I know it's got hot, it's overheated, and you might want to send a signal across to your application, which would throw an event in your application. You say, heck, change that to red, send a message, get somebody in to look at, understand what's going on with the temperature. And if I come across over here, in fact, I'm going to try this. Now, the thing that I've installed in here is the All Join option. You go into Visual Studio, goes into Tools, Extensions and Updates, and in here you'll see the installed one. It's called All Join Studio. And you install the All Join Studio, and that adds up this new interface up here. And what I can do, and we'll try this for a bit of fun. Yeah. So what I did, there are two ways you can do this. You can either go out into your network and basically look for all the All Join capable devices which are sending out broadcasts. And you can see I've got one here for my rover. So there goes the one for rover, and the other one is my sonar. So those are the two All Join XML. There's effectively, you can go and inquire on them. It will pull back the XML from those devices, and then inside Visual Studio, we will create all the libraries for you and then give you nice interfaces into those capabilities. So that's kind of how that works. Or you go and browse your own one and click on OK, and you go and import that in. And yeah. So those are two ways. You can either build your own XML, or you can go out and inquire on your All Join libraries out there and go and build them. Alrighty, so All Join. And I don't think you can underestimate really the power of that, and that it's interop, it's across the industry. Go up into the All Scene Alliance website, and there are hundreds of manufacturers who are participating in this overall IoT interop. And it deals with device discovery, the security, all those types of things. It magically does all that for you as part of that overall specification. And this was just the All Join example that I've just shown you. Now, one of the things that you really must do if you do play around with this technology, and I think I lost half a day on this, is that you must give your application the All Join capability. So inside Visual Studio, you can go into the package manifesto, I think whatever it is, you go along there to Capabilities tab, and you'll see that there is All Join. So you'll go and run these demos, you go back and craft up your own, and you'll wonder why the hell it exceptions on a security or capability. So you must go and give your All Join application. We've done that. Okay, and then kind of one last thing. I like to give a bit of a plug for this platform. So for a lot of people, building something like this, Arduino-based Sonoscope and things like that, is really way more pain than you really want to go and do, or maybe your interest level. One of the great ways of getting on board with Windows 10 IoT Core is with something called Grove Pi. Has anyone heard of Grove? There's kind of like a, it's not a standard, but it's become like a de facto standard, I guess. And there's a standard set of plugs, and there are a whole range of sensors out there, and people have gone out and written the drivers for them. That's the thing, that you want drivers for these things. So people have written the drivers for the ultrasonic sound sensors and all those types of things. And you go and build out your application, you get in the Grove Pi drivers into your Visual Studio project, plug in your devices into Grove Pi, and voila, you can start building your application. So if you really don't want to monkey around with hardware, and you say, look, I've got this idea, I want to play around with it, things like that, or maybe your kids and things like that, you want to get involved, then really recommend you go down that line. Now, in terms of getting started, as I said, dev.windows.com/IoT. Microsoft Hackster is a great place. Drivers, you invariably, when you go and look at a project, you want to kind of say, well, I want to go and do distance, I want to go do temperature, I want to go and do humidity, or whatever it is. You invariably need to make sure that there are device drivers out there for Windows that people have written, or we have written, or other people have written. So you'll find there's a whole stack of drivers out in github.com/ms-IoT. I've written a whole lot of drivers as well. So I'm up there on GitHub glove boxes, and I've published my drivers up onto NuGet. And I think this guy Pori had done a whole lot of stuff around here as well. But basically, when you start thinking about your applications, make sure that there are device drivers out there. The other question I kind of get asked about is, where do I kind of buy stuff from? And I suspect you've all got different places. I tend to hunt around eBay, and Amazon a great place. Little Bird Electronics is based here in New South Wales. Tronics Labs is based in Victoria. Core, I can't remember their word, maybe even Perth. RS Components are everywhere. Element 14 and JCars. Those places, typically if you're looking for something, or eBay, by far the cheapest if you're happy to wait from a month to 6 weeks, and you can get it for like a fraction of the price. If you want it now you go off to Tronics Labs or RS Components or these folk, and you can kind of get started with the technology from those guys. And that's really the session. So hope you give you a bit of a sense of what we're doing around Windows 10 IoT Core. It's this whole, as I said, instead of embedded sitting outside of the Windows, it's part of Windows. It inherits all the technology. The release cycles are the same. So when we bring out the anniversary update for Windows 10, voila, the anniversary update will appear on my Raspberry Pi as well. So all those technologies, all the security, all the patches, all those types of things, they invariably end up with the smallest devices and cheapest devices as well. Language of your choice, you can be part of the, in terms of kind of getting involved. As I said, there's an IoT lab out the back, so that if you want to have a bit of a play around with it and just kind of give things a go and fire it up. And that's pretty much it. So are there any questions? Yo. Yep.
Is there a way to sort of limit which other all-join devices can connect to your all-join endpoint?
Oh, absolutely.
Or is that better than like a commercial sort of?
No, you have classes. So you would only subscribe to the stuff that you were interested in. Yeah. If you were a light manufacturer, then your application would only talk to the lights.
I'm more thinking about like if you were going to use, say, it for an enterprise sort of solution.
Yep.
And you wanted to keep all your enterprise stuff working together for one company.
Yep.
You didn't kind of want other different companies coming in on that. Would that be better just to make an enterprise sort of wrapper on that, or would you just not use all-join for that?
No, I think you could go and use all-join on that. You'd go and you can use security on it. So you tie down the security on it. You can put in to the platform. You could go and distribute a key, for example, and you could be a whole lot of different ways. You might say, okay, well, I've got in there. So the way you probably work, you'd probably connect over all-join. You'd probably go and set a property on the platform, on the device, and on that setting that platform, it might be the key, the shared key, or whatever it is. And then any methods would have to provide the other part of that key to be able to go. So you're going to do it ways like that. But really, this whole thing about all-join is it's this kind of universal fabric, and then you can go and build stuff out there for it. It's a fantastic initiative. I'm not saying everybody's on board with it by any stretch, but a lot of people are, and it really is well and truly worth looking at. Alrighty, I think that's pretty much it. I've got a funny feeling I'm probably due to start my next session about now, and given it's only me, I don't have to overrun. Okay, so the next session here will be about more kind of the services side, and I'll kind of give you a flavor of that. But anyway, I think we're finished, and if you want to stay, and off to your next sessions. Thank you very much. Cheers. Thank you.